Okay, so at first we had said we were going to go to the suite because that's where we were going to investigate. And then we were going to go to Discovery and I wanted to
here to have a conversation about conditions for the mean value theorem. Alrighty, friends, mean value theorem. I say mean value theorem, two theorems, two conditions immediately come to mind. Delia, what's one of them?
It has to be, this function has to be continuous.
Oh, so good, almost perfect. Okay, I know you started off with it and you saved yourself, and I appreciate that. So she said the function has to be continuous. That's kind of true, but it's more than that.
The function has to be continuous on the closed interval.
Oh, thank God. MVT, thank you. So much better than Delia. Okay, f of x continuous. Delia, I love you. You're a wonderful human being. The function has to be continuous on the closed interval. And Jackie?
And then you have to find the derivative of f of x.
Because the second condition is...
It has to be differentiable.
Oh, did you
The
hear
function
it?
has to be differentiable.
The function has to be differentiable. Where?
On the open interval.
On the open interval. So if the function is continuous on the closed interval and differentiable on the open interval, these are the conditions. What's the promise? What are you guaranteed? You have continuity on a closed interval, differentiability on the open. Kevin, what are you promised?
So the MVT applies?
Okay. Yes, the MVT applies. That's, yeah, no lifesaver for that. Okay, the function is continuous on the closed interval, differentiable on the open interval. The mean value theorem applies, but what does it tell you?
F prime of C equals FB minus F.
F prime of C equals F of B minus F of A over B minus A. I like it, I don't love it. It's good. It's good, but it's not de Rosier quality. There's something missing here. F prime of C is equal to F of B minus F of A over B minus A, but there's something special about C. Really special about C.
Slope over tangent.
No, you've got it. F prime of C is slope of tangent. F of B minus F of A over B minus A is slope of secant. But there's something special about where C lives.
Between A is less, A is greater than.
Yeah, you don't know what you're saying anymore. Okay, the thing about C is that it is inside the interval. It's between A and B. It's not an endpoint. And all the friends are okay? So we've looked at L'Hopital's rule, which is about limits and indeterminate forms. We've looked at the mean value theorem, which is about derivatives, secant lines, tangent lines. And today we're going to look at something completely unrelated to both of those two things, called absolute extrema and the extreme value theorem. This has nothing to do with the mean value theorem and nothing to do with L'Hopital's rule. It's just another application of the derivative. And I think part of what makes this unit so hard, all these ideas are kind of separate ideas. They don't necessarily connect. But we're going to be okay, because we're the Rosiers. We do challenge with a smile all the time. All right, so let's get started. This is going to be really heavy vocabulary in the beginning, and then I'm going to blow your mind with the calculus. Okay, so in the notes on page 19, I'm going to take you back in time, and I'm going to ask you to draw for me, please, a relative maximum. I say relative maximum. We've heard this phrase before. Can you guys draw for me what comes to mind? A relative maximum. Naum's got it. Some of you are participating. Some of you are like, why, God, why? Okay, Jose's got some ideas. I said relative max, and just about everybody did this thing, right? This is what a relative max means to us. Jose did that guy there. When I say relative max, these are the things I want you to come to mind, okay? Now, how do I show that something has a relative max? How do I show a function has a relative max? We've been here before. What would you do? One more time?
The function goes from positive.
The function goes from positive to negative. I disagree.
The derivative of the function.
Right. So one more time, I heard you say, Jose, the function changes from positive to negative in a relative max. Are we okay that that's false?
Yeah.
What does change from positive to negative?
Derivative.
The derivative. F prime makes a change from positive to negative at x equals c. This is true about the derivative, yeah.
The function has a horizontal tangent line?
Actually not true. And that's why I wanted to get both of these here. Does the function have a horizontal tangent line in both cases?
No.
Horizontal tangent line over here, but what's happening here? There's a cusp point, so that's not a horizontal tangent line. What is true is that the function changes from being increasing to decreasing at x equals c. That is true. In both cases, the function was increasing, and now it starts to decrease. That's what makes a relative max a relative max. Okay, relative min. Hopefully relative min. Everyone's thinking about this. Everyone's thinking about that guy there. Everyone can tell me the next two statements. What happens with f?
F of x changes decrease to increase.
Decreasing to increasing at x equals c if I'm looking at the derivative.
And then f prime of x changes from negative to positive.
Love it, Jackie. Nice job. F prime changes from negative to positive at x equals c. 100% review. Everybody's okay. We're good? Now, some textbooks, they're going to say relative max or relative min. They're also going to use the word local max or local min. It means the same thing. These are just synonyms. Okay? But here comes the new idea. I want to introduce you guys to this idea of an absolute maximum or an absolute minimum. And it's actually, it starts off easy and then it's going to rock your world. Is everybody okay if I erase?
Yeah.
Okay. Absolute max, if I said something is the absolute minimum, what comes to mind? What other words come to mind? This is the absolute minimum. This is the, maybe you're focusing on absolute value. The absolute minimum. I looked at everyone in the senior class. This student's GPA is the absolute minimum.
The worst.
It's the worst. It's the lowest. Someone's like, it's mine. No. Okay. Absolute minimum just means the lowest. Okay? So the definition I want for absolute minimum is going to be the lowest point on the curve or on the graph. Okay, that's like the friendly definition. I say absolute minimum, you're thinking the lowest point. So absolute maximum is going to have to be the highest point or the greatest point, the highest point on the curve. Now, here's where my notation is going to change things up for you guys a little bit. The lowest point on the curve is what I mean when I say absolute minimum. Here's the calculus though. What I'm going to say is that f of c is less than or equal to f of x for all values of x. Values of x on the interval a comma b.
It's greater than or equal,
No, for absolute minimum, the lowest, f of c is less than or equal to f of x. For all values of x on AB. For a maximum, we're going to say f of c is greater than or equal to f of x for all values of x on the interval a comma b. I think we're all okay with the friendly definition, right? It's the lowest, it's the highest. The calculus definition, though, f of c, we're talking about the y value, is less than or equal to all the y values on this particular interval. So, for example, let's talk about the lowest GPA. Your GPA is the absolute lowest at Yes Prep. What I'm implying is I'm looking only at seniors at Yes Prep, and I'm looking at GPAs, and of all 100 and some odd of you guys, somebody has the lowest, and we'll let that person name remain invisible. Are we okay? Does that person have the lowest GPA of all students in Houston?
No.
maybe.
Do they? Maybe it is the lowest GPA. You're really pessimistic. It might even be the lowest GPA of everyone in Houston. Is it the lowest GPA of everyone in Texas?
We don't know.
Could be, but we don't know. We're comparing to Yes Prep and saying this particular student, God help them in the college application process, has the lowest GPA. Are we good? Okay, good. Context matters. So with that said, I want to see what you guys can do for me with coming up with some sketches. There's 5 scenarios at the bottom. Going to give you guys just a minute or two. We'll do one together. Situation number one, I want a function that has a relative minimum, which is also an absolute minimum. Take a little bit, come up with a sketch. It doesn't have to be a parent function, but give me a graph that has a relative minimum that's also at the same time an absolute minimum. I just want to do a quick spin through the room. Relative min, also an absolute minimum. Lots of different ways you could do this.
You have to draw it, right?
Yeah, just a sketch. Just a sketch. Good sketch. Pedro's got good curves. Jackie has a completely different curve that works. Kaylin's got one that works. Abraham's going totally exotic. Naum's keeping it basic. Just about everybody has something that looks like that. We're okay? I need to be convinced. Why is this a relative minimum? Jose in the back. Why is this a relative minimum?
Yeah.
What does it take to be a relative minimum? Go back to the definition if you need to.
F of x goes from increasing to decreasing.
Is the graph changing from decreasing to increasing at this point? Okay? Okay, what about absolute minimum? Absolute minimum is a different flavor of minimum. There's something else that has to be true to be the absolute minimum. Is this also at the same time the lowest point? We're okay? So this guy here is a sketch that meets both criteria. See what you can do with the next couple. Well, just walk around for a minute or two. Situations 2 through 5. I just want to sketch. Function which has both an absolute maximum and an absolute minimum. Three people? 4 people? Oh no. Oh no. It's happening again. Just about everybody that I just walked around to has this graph.
No.
And this graph doesn't work. The situation that I'm asking you to describe is a function that has both an absolute maximum and an absolute minimum. What's wrong with this graph? Why doesn't this graph work? Go back and read the definition. Go back and read your definition one more time. Absolute max and an absolute min. Ashley, what's the problem?
Is it because the graph is infinity and it's asking for values on the closed interval?
I didn't even mention a closed interval, but you've got the right idea. Where's the highest point?
Infinity.
That doesn't count as a point.
Yeah.
Right? You guys are like, well, it's going up here. There's no actual point up here. There's not a physical point. I think a lot of you guys, I'm curious, did most of you say, like, this is the absolute maximum? That's the issue? What kind of max? This is a relative max, and this guy over here? Relative minimum. Not an absolute max, not an absolute min, because this guy keeps going up. Now, a couple of folks did something really clever. They did this. Maybe they weren't even trying to be clever. It was accidental. They got lazy. They stopped drawing. Is there an absolute max?
Yes.
Where? Like this guy over here is the absolute max because it is the highest point. Is there an absolute min?
Yes.
Absolutely, there is an absolute min. Last class they got a little bit clever and they said, okay, what about that? Does that graph count? Absolute max?
Yes.
Yeah, there's an absolute max. This point is higher than any other points in the curve. Absolute min?
Yes.
Yeah, maybe depending on how you drew it, it's this guy. Okay, finish up. Get the last 3 more.
Can you check mine?
I would love to. I can think of no better way to spend the next minute. Okay, an absolute max but no absolute min. Love, relative max which is not the absolute. So where's the relative max that's not the absolute max?
This one.
Love it? Don't love that one. Don't love that one, but that last one's tricky. Okay. I swear you drew the same thing 5 times. Okay, function which is an absolute max. Where's the absolute max? Where's the absolute max? No absolute max, because we're just going to keep going. Arrowheads would be good. A relative max which is not the absolute max.
It's just always going to stay there. If I start measuring, I'm like, get it out of there. And then you'll be right there.
Alright, we've got this. A function which has an absolute max but no absolute min. I think we're good. Okay, a relative max which is not an absolute max. I see a lot of people doing maybe something like that. Here's a relative max, but this guy's the absolute max.
Yeah.
Alright, I'm curious, did anybody come up with a graph that doesn't have an absolute max or an absolute min? Hold on one second. Beto, what do you got for me? Beto, as well as some other folks, and I hope the kids in Ohio can see this, have drawn a line. Roberto, you did the same thing, right?
Yeah.
Okay. This graph we need to talk about. This graph is a little confusing. We're going to come back to it. Did anybody else come up with a graph that doesn't have an absolute max or an absolute min?
Isn't this one like the one we drew here?
Okay. The one that we drew earlier is what Jackie's saying. Like this guy here has no absolute maximum and has no absolute minimum. I think we're okay. I just want to make sure we get definitions, different definition for relative max than absolute max. We get this under control. Jose. What about a circle? A circle is not a function. So we're going to stay away from functions. But thank you for the question. We're going to come back to this guy in a little bit. Not right now.
Okay.
All right, so now I want to sort of make this a little bit more concrete for you. This should be very, very comfortable, Kaylin. All right, next round. I want to make sure the vocabulary is tight. Tight like my pants used to be before there was flooding. Hurricane Harvey, it's a great diet plan. You're so stressed all the time, you don't want to eat. All right. Don't worry, I'm still eating. All right. So just like the conversation we talked about with our poor friend who has the lowest GPA at Yes Prep, that might be different from saying the lowest GPA in all of Houston. It could be lowest GPA in all of Texas. So we've got a graph, and what I want you to do is on the identified intervals, identify for me where the relative max is, where the relative min is, where the absolute max is, where the absolute min is. So let's do this first one. On the interval -2 to 4, I like to think about this as putting my blinders on. I look from x equals -2 over to x equals 4. I only see this part of the graph. Take a minute. Identify absolute max, absolute min, relative max, relative min. Where are they? I want coordinates like an x and a y. If you want to use the rulers to kind of like put your blinders on, that's okay. All right. Evelyn, have you figured out the relative max on the interval -2 to 4? 0 to 2. Wait, a relative max, remember to be a relative max, we need the graph to change from increasing to decreasing. So where does that happen? It should be like right over here at this point. So your relative max should be at the point 0, 0. Okay, Jose, Jose P in the back. Relative min?
Is it 2 and -4?
Okay, 2, -4. Is everybody okay with that being the relative min? Yes. Right, because that's where the graph changes from decreasing to increasing. Okay, Jackie, absolute maximum. Do you see an absolute max?
Yes.
Where?
It's 0, 0. Right?
0, 0 is the absolute max?
Yeah.
0, if it's the absolute max, then what you're saying is this is the highest point on the graph. Or is there a higher one?
Yes.
There is a higher one.
Where's the higher one? You've got your blinders on. You can only see from -2 to 4. Is there any point on the graph that's higher?
416.
And it should be this guy over here.
So it doesn't have to be a curve, like a
And I'm so glad we're having this conversation. To be an absolute max, what has to be true? The highest point. Don't overthink it. Just means the highest point. Okay, and Jesus, absolute minimum, do you have one? Where is it? -2 and -20. Everybody mostly okay? Whenever we're going to talk about absolute max, absolute min, relative max, relative min, I'm going to give you some domain restrictions to really get you to think about this. So take a minute, finish this off. You guys should be just fine. Rows 2, 3, and 4, please. Keep paying attention to those intervals. The intervals are going to matter. Now I can give you some tissues. I had some tissues. There were some tissues out there. Here you go. You're big and manly. You can handle it. Okay? Stay with me. Okay, if all goes well, in your second row, you were only looking from -2 to +1. The relative maximum is at 0, 0. But on this interval, there is no relative minimum because we're only looking between -2 and 1. We don't see the fact that there's a change from decreasing to increasing. Your absolute maximum is 0, 0, and your absolute minimum is -2, -20. How many of you guys got all 4 of those right? Okay? It's just a difference in paying attention to the adjective. Relative max, we're changing from increasing to decreasing. Absolute max, highest point. Okay, row number 3, now we look from -infinity to 2. If I get to see all the way from -infinity to +2, but nothing else, where's the relative max? Still 0, 0. Where's the relative min? Ashley, why not? You're 100% right, but why no absolute min?
Like it's in going to infinity. Oh.
From -infinity to 2, why is this not a relative minimum?
Because it's not from.
Somebody help her out. -infinity to 2, why do we not want to say relative minimum at 2, and what's wrong with saying that?
Because the function isn't switching from decreasing to increasing.
You don't actually get to see, does the function change from decreasing to increasing, which is what we need for a relative minimum. Okay? What about absolute maximum?
0,
0, 0, absolute minimum? There is none at all because we don't have a lowest point. And if you made it to the last row, if you go all the way from -infinity to infinity, 1, you want to make sure you get these written down. You have a relative max at 0, 0. You have a relative min at 2, -4. You have no absolute max. You have no absolute min. Is everybody feeling like we've got this under control?
Yes.
It's a lot of definitions right now. That's about to change. Jackie?
So it wouldn't be for the absolute maximum and absolute minimum since it's like infinity. It's not like defined or anything. We can't put positive infinity and negative infinity.
Right. We're never going to have an answer of positive infinity is the absolute max because it's not a point. You're never going to have an answer of negative infinity because it's not a point. All right, so let's move on, shall we? We've got the basics under control. Now it's going to feel like our typical calculus class experience. Lots of fun. Lots of fun coming your way. All right, I need somebody in a loud, strong, proud voice. Beto, can you introduce us to our next named theorem?
The extreme value theorem.
Yep, keep going. Nice and manly.
If f is a continuous function on the closed interval a less than or equal to x less than or equal to b, then f must have an absolute global maximum and an absolute global minimum on that interval.
Thank you for changing your voice when you speak things that are in parentheses. Absolute global maximum, absolute global minimum. Okay, this is the extreme value theorem. I want to read it one more time. Like, pay attention to this. If you have a function that is continuous, we know what that means, right? No holes, no jumps, no breaks, no vertical asymptotes. On the closed interval, so this is like condition number 1. Condition number 1, continuous. Condition number 2, closed interval. What does the extreme value theorem promise you? What are you guaranteed by the extreme value theorem?
Must have an absolute.
There must be an absolute maximum and there must be an absolute minimum. Think about that for a second. Really think about that. How many of you would just say that just makes sense? If you think about a continuous function and you have a closed interval, you have a starting point and an ending point. How many of you just say, of course there's going to be an absolute max and of course there's going to be an absolute minimum? Maybe 1, 2. Sketch it if you have to. Sketch, take a moment. Sketch a continuous function on a closed interval. Find the absolute max. Find an absolute minimum. Continuous function, closed interval. Does there have to be an absolute max and an absolute minimum? Last class they were convinced they found a counterexample. Okay, and the counterexample that everybody thought they found was this guy over here. Is this a continuous function?
Yeah.
Yes.
Absolutely. Now you might be like, well, what's the closed interval? So like, here's the closed interval. Is there an absolute max?
No.
Is there an absolute min?
No.
And that's what everybody was agreed to last period. They're like, wait, there is no absolute max. They're all the same. Go back to your definition from page 1. What did I say about an absolute max? Go back to the definition. There's something really, really picky.
Highest point on the curve.
Highest point, there doesn't seem to be a highest point on the curve. Look at the calculus explanation of it. To be an absolute max, what had to be true is that f of c had to be greater than or equal to f of x. Is there some place on this interval where the y value is greater than or equal to all the other ones?
No.
Let me ask that again. Is there a y value where the y value is greater than or equal to all the other ones?
No, the one that stays the same.
You guys are missing the important piece.
Yes.
So there could be
Greater than or equal to. So is there an absolute maximum? Where?
At that line.
They're all absolute maximums. Any point that I pick has an absolute maximum. Is there an absolute minimum?
Is that the same thing, right? It's
Every single point is an absolute max and every single point is an absolute minimum. It's any continuous function on a closed interval has an absolute max and has an absolute minimum. All right, I need my twins. Can I get Jose and Juan to come on up with the packet? You need strong, manly voice. Come on up, gentlemen. I'm going to make you YouTube famous. At the end, if you want to like share your email addresses so the ladies in Ohio can send you their pictures, invite you to prom. I am helping. Come on, Juan, you can do this. I have faith in you. You're looking great today. It's all right. We're going to get over here. This is Juan. And here comes Jose. Juan, you are going to be the wise wizard. And Jose, you are the mighty maverick. They have not had a chance to rehearse these lines. They don't know them for a fact. Oh, don't be all cowardly and off camera. All right, Juan, you're the wise wizard. You've got your script in front of you. I need action. Go.
Okay, I get it. There's an absolute extrema and relative extrema. But what's the big deal?
Well, I was chatting with Mr. D last night. He said that's a lot of problems.
I said what?
There's a lot of problems. We are going to study in the coming week. Will involve domain restriction.
And I care why?
Well, with these domain restrictions, well, we always need to check the endpoint. Sometimes the relative maximum and minimum points will even be in the interval. We are restricted to.
Alright, I'll be sure to check the endpoints. After all, I do want to do well on the AP exam.
That's the spirit.
Oh my God, that was so emotional. I almost cried with you. That's the spirit. Juan, keep going.
Wait.
Hey, I noticed that the extrema value theorem says that the function has to be continuous on a closed interval. Do you think it makes a difference if the interval is open or half open?
I have no idea. This asks our computer teacher. They know everything.
I do know everything. Thank you so much. Well done. We should applaud. Next time I know who to pick. Wow, that was something. Okay, extreme value theorem. What are the two conditions again?
Closed interval.
Closed interval and continuous function. If you have a continuous function on a closed interval, guess what happens? Absolute max and an absolute min. I want to look and see what happens. What if you take away one of the conditions? The function must be continuous in order for the extreme value theorem to be applied. What about the function f of x equals 1 over x? It's a little bit off. What about the graph of f of x equals 1 over x? Can we use the extreme value theorem?
No.
What does that graph look like? F of x equals 1 over x on the interval -1 to 1. Anybody have any problems with this function? If you're not sure, sketch it on your paper. F of x equals 1 over x. You know what this looks like. Jackie knows what it looks like. F of x equals 1 over x.
That's not what that is.
F of x equals 1 over x looks like that. We're on the interval -1 to x equals 1. I heard Jose say we've got a vertical asymptote at x equals 0. Can I use the extreme value theorem? To use the EVT, I need a continuous function on a closed interval.
No.
I don't have a continuous function. Is there an absolute max?
No.
There's no absolute max because
The infinity.
there's no highest point, right? This guy continues to go up forever and ever and ever. Is there an absolute minimum? Nope, we just continue to go down forever and ever and ever. So no absolute max or absolute min. All right, let's keep going. Okay, second one, you can only apply the extreme value theorem on a closed interval. Let's consider the same function again. F of x equals 1 over x. On the interval 1/2 to infinity. Here's x equals 1/2. This is where I put my blinder on. And what I get to see is the function forever. Is there an absolute max? Is there an absolute max? If so, where is it? Like this guy right over here, is everybody okay? This is your absolute max? Is there an absolute min?
No.
Right? Is there a lowest point? No, this graph continues to decrease and decrease and decrease forever. But what if I said, oh, just look on that interval?
Yes.
Then you're going to have a lowest point. It's wherever you cut it off. Are all the friends okay?
Yes.
Okay, good. I think when you have the graph in front of you, absolute max, absolute min should be easy. What's going to be tough is when you don't have the graph in front of you, and this is where we're going for the next 12 minutes or so. And if we're lucky, we'll get through one problem. I love these kinds of problems. Yeah, if we're lucky. If we're lucky, we're going to get through one. But for those of you that like checklists, you like your criteria for success, as we might say in the business. When we're looking for absolute extrema, there's a couple of steps that you're going to run through. So take a bit. Look at the bottom of page 21. Get ready for awesome sauce. Oh, you'll know when you taste it. Awesome sauce, not Szechuan sauce. Can't even say Szechuan sauce. And now kids in Ohio know that I can't say Szechuan sauce.
Right.
I'm gonna try it. They said they're gonna do it.
It's like flavors are like open.
All right. Here we go. Excellence is coming. So excited to work with you guys on this one. I may not have provided you nearly enough room, but this is what it's going to look like tonight. This is what it's going to feel like tonight. You're going to be asked to determine the absolute maximum and absolute minimum values for the function f of x equals x minus 4 square roots of x plus 1 on the interval -1 to 8. My first question for you is, should we even expect an absolute max and an absolute min?
No.
Yes.
Should we even expect absolute max and absolute min?
Yes.
If you're expecting an absolute max and an absolute min, why? We have a closed interval. That's one of two conditions. That's one. Okay? You guys are like, oh, right here, closed interval, good. The second condition is really important. What's the second condition?
Continuous.
Continuous. Is this continuous? I might want to be a little careful here.
How do you know?
How do you know? Okay, let's see. Am I dividing by 0 at any point?
No.
No, never dividing by 0. Are we taking square roots of negative numbers?
No.
Are we taking square roots of negative numbers?
No.
These are the options. Delia has narrowed it down. Yes and no.
No.
Are we taking square roots of negative numbers? Go for it.
Because when you're looking, if it's continuous, it has to be on the closed interval, and it says -1.
On this interval, is it okay to take square roots of these values?
Yes.
Yes. So continuous on -1, 8. So the EVT applies. Or the EVT, the extreme value theorem. Continuous function, closed interval. I'm going to have a max, I'm going to have a min. Last period, I guess I lowered my expectations a little bit, and I let them take out their calculator to graph the function. I am not going to do that with you all. I have high expectations. Okay? So here's the thing. When we look for absolute maxes and absolute minimums, there's two places that we check. Okay? We're going to check endpoints. We're going to check the endpoints, and we're going to check for what I'm going to call internal candidates. Internal candidates are your relative maximums and relative minimums. It's going to be places where the derivative is equal to 0 or the derivative does not exist. If you're going to have an absolute max or an absolute min, it happens at an endpoint, or it happens at a relative extrema, a relative max, relative min. Now, good news, we know what the endpoints are. The endpoints are -1 and +8. Okay? The internal candidates involves finding the derivative, and I want to get a good model here. We're going to find the derivative. You guys should be really good at finding the derivative at this point. Okay? I see x minus 4 times the square root of x plus 1. I heard Jose up front say we're going to do a chain rule. You actually are right to say that there's a chain rule. X minus 4 square roots of, okay, what's the derivative? Everybody knows how to find this derivative. 1.
1 over 2 square root of x.
Okay, derivative of square root of x plus 1 is 1 over 2 square roots of x plus 1, but be careful. Okay, that we're multiplying by that 4. And somebody earlier told me chain rule. So you multiply by the derivative of the inside, which is 1. Okay, so that's your derivative. And if you had forgotten to write the 1, it's going to be okay. It's okay. Okay, so 1 minus 4 over 2 square roots of x plus 1 is your derivative. For those of you that like simplifying, you're going to make it 1 minus 2 times the square root of x plus 1. That's your derivative. The reason that we're looking at the derivative is we're looking for relative extrema. We're looking for places where the first derivative is equal to 0. We're looking for places where the first derivative might be undefined. Well, if f prime is equal to 0, That just means set the derivative equal to 0 and solve that equation. So 1 minus 2 over the square root of x plus 1, we're going to set that equal to 0. And we're going to solve that equation for x. No longer a calculus question. It's an algebra 2 question. You're going to add one? Subtract one?
Yeah.
Now, certainly we can do that, and you can say negative 2 over the square root of x plus 1 equals negative 1. I want to use this as an opportunity to introduce you to a new idea. Not even a new idea, but back in high school when I was running in the gangs, my nickname, I was Fraction Killer. I had so many dots on my knuckles, I was killing fractions every day. My favorite way to kill off the fractions was multiply by the lowest common denominator. Lowest common denominator here is the square root of x plus 1. Check it out. Multiply everything through by the square root of x plus 1. 1 times square root of x plus 1, square root of x plus 1, minus 2 over the square root of x plus 1 times the square root of x plus 1 is just 2. 0 times the square root of x plus 1? 0. That problem just became so much easier for you to solve. You want to get in my gang, you want to be a fraction killer. So take 30 seconds, finish this off. Square root of x plus 1 is equal to 2. We're going to square both sides. And I think we get x equals 3. Okay, we're good. All right, good. This guy here is your candidate. It's where you might have a relative max or a relative min. Okay, and this is, I kind of got us a little off track last period because a lot of folks said, now wait a second, what I want to do is I want to do now my number line and figure out if we have a relative max or a relative min. And we can do that, and that's great. But all that I care about is, do I have an absolute max or an absolute min? I just want to know highest point or lowest point. So in the check stage, here's what you do. You're going to check the value of the function at the endpoints, and you're going to check the value of the function at the candidate or candidates. These guys here are your endpoints. Endpoints. This guy over here is your candidate. Okay, let's do it. F of negative 1, plug negative 1 into the original function. Negative 1 minus 4 times the square root of negative 1 plus 1. Negative 1 plus 1 is going to be 0. Square root of 0 is 0. Times 4 we get 0. I think we get negative 1. Okay, what about f of 8? That's 8 minus 4 times the square root of 8 plus 1. 8 plus 1 is 9, square root of 9 is 3, times 4 is 12. This is negative 4. F of 3. 3 minus 4 times the square root of 3 plus 1. That's 4, square root of 4 is 2, that's 8. Is that negative 5?
Yes.
Okay, so my question for you all, what's the absolute maximum?
None. We don't know.
We've already established that the function is continuous on a closed interval, so there has to be an absolute max. What's the absolute max? Absolute max as a point, I want coordinates. The absolute max, f of negative 1 is negative 1, f of 8 is negative 4, f of 3 is negative 5. Which one's the absolute max?
Negative 1, negative 1.
Negative 1 comma negative 1 is the absolute max.
No.
Where's the absolute min?
3, negative 5.
If I look at those values, it's this guy over here, it's 3, negative 5.
User.
So you've got the absolute max, you've got the absolute min, and you didn't have to use the calculator.
Oh my God.
You've got 1 minute left, you got your calculator. I want you to sketch the graph on this particular interval and make sure I didn't just lie to you all.
You did.
Because sometimes I do. I wouldn't lie to you all. You okay there, Cowboy?
Yeah.
Getting the calculator out. Sketching calculator.
Why is she biting my lip?
Your calculator's dead. Good thing you can charge it up and do all the things.
The function. And that's where you do the closing.
Oh, yeah, this right.
Just put it on
No,
there.
it's not. It's not right. He's not.
Okay, some of you are screaming that it's right even though you didn't pick up a calculator or even try to graph it. Jesus is just so trusting. I'll have to remember that.
Oh, you're right. No, you're right.
I know I'm right, but check it on the calculator. Make sure I didn't actually lie to you. 'Cause I lie to Kevin all the time. Oh dear God, let me just do that. Okay, tonight's homework is assignment number 54. It's going to be 3 problems like this. You've got a great model to follow.
I was about to say he lied to me again.
Yeah.